We've done so much with equations, it's time to talk about inequalities in mathematics. So in this lesson, I want you to watch how I interpret what an inequality is and how I can solve simple one-step inequalities. That means representing them on a number line and understanding what the solutions of an inequality are in the context of the problem. Unlike equations, there will be more than one answer here. And by the end, I want you to think about how I differentiate between open and closed circles on a graph and what that really means as I'm graphing points and as I translate that inequality. Before we jump into some models, I want to go into some vocabulary and we're going to talk about these symbols. And we're going to use them using just an AB for helping us understand this. Now, the other thing I want to put into these notes for a little bit is some symbol stuff that we know from when we're younger. And the first one is, I know a lot of schools do this and they make this into Pac-Man. They say Pac-Man always goes for the bigger numbers. That helps to see like which of these would be the bigger numbers. That's really helpful. And we're going to talk about what this line means underneath. And it's really the combination of two symbols. So let's start with the first one. And it's called greater than. Now for each of these, I read the sentence from left to right. So I would say A is greater than B. Other ways I can say it, I can say more than, is over, exceeds. Any of those words work. And I'm going to show you what this means. We're going to have an open circle. So I'm going to make a number line so you can see what this looks like. And let's say I have x is greater than 5. So I'm going to put the 5 here in the middle. And I want x to be all the numbers that are bigger than 5. So watch, I'm going to do Math Marvels. I'm going to put a circle around the 5. And I want all the numbers that are bigger than 5 for infinite for right now. Every number bigger than 5, just not 5. So I can have 5.01. That's bigger than 5, but everything's bigger than 5. Let's look at the next symbol. And it's opposite, less than. So I would say A is less than B. Again, I always read from left to right. So other ways I could say it is, I can say is under, fewer, below, all different ways. And it would also be open. So let's say I have x is less than 5. Okay, so I'm still going to have a number line. I'm going to have it at the 5. I'm going to open around the 5. And I want x to be all the numbers to the left of 5. That's what I want. So I want every number to the left. And notice how I put my x so I can figure out which ones I want, the ones on the left, on the right. If it's on the left side, it's less than. If it's on the right, it's bigger than. So that always helps me out as I'm trying to figure out my graph. So let's look at these with those underlines in them. Those underlines are combinations of two symbols. It's greater and less than plus an equal sign. But instead of it looking like this, they just add one equal sign to the bottom. That's all it means. So I would read this one as greater than or equal to. So I would say A is greater than or equal to B. Other ways I can say this, I can use the terms at least. I can say is not less than. Is not under. You kind of get the idea. But these are going to be closed circles. I'm going to show you what this means. And what if I have x is greater than or equal to 5? So here's my number line. Here's 5. Here's x. So I would want, I can include 5, so it could be equal to 5 and every number bigger than 5. That's how that works. And the same thing is going to go for its opposite, less than or equal to. So same thing. A is less than or equal to B. Other ways I can say this, I can use the term at most. So the most it could be is this number, is not greater than. Whatever that number is, does not exceed, is not of more value. Like I can just use all those different words. It's also going to be closed. And it would look kind of the way you're noticing all of this. I'd have a number line, I have 5, and I want all the numbers that are less than 5. It's the left side. So I would make a circle at 5, and I would want every number to the left. So that means you can include 5. So at most is 5 and everything less than. So that's what I like about using terms like at most, at least. You're going to see those all the time. All right, and the last one we just have is equal to. So that one kind of only goes for actually equations. And we know that it just says A is equal to B. So exactly B. And this would also be a closed circle. So if I have, for example, x is equal to 5, here's my number line, here's 5, and all I would do is boop, make a circle at 5, because there's x. Okay, so I hope this helps you with some of the language. We're going to use a lot of these. I find a lot of kids get confused with these terms. At least is a confusing term, and at most. So I want you to look out for those. More than is pretty common. Less than or is under is pretty common. But the at least and at most trips up a lot of kids. So make sure you jot this one down to your notes. And we'll get a lot more practice with inequalities. Okay, let's jump into our first problem together with inequalities. We're going to try and name 3 potential solutions that make this inequality a true statement. And you can see how our graph is going to help us prove our thinking. Okay, so here's the first part. We're going to name 3 potential solutions to x is greater than or equal to 2. So looking over here, notice I have a closed circle. So that means I can include 2 and any other number after 2. So let's think about potential solutions. I can use 2 as a solution because it says x can be equal to 2. And that one works. 2 is equal to 2. And how do I know? Because it's underlined, math marbles. Remember, this is just a way of saying equal to plus the greater than symbol. They're just added up together. So that's one potential solution. I could also use another number. Again, I'm using any numbers on the right side of 2. So I can use 3. 3 is greater than or equal to 2. That's a true statement. And I'll use 10, even a number that's not even on this number line. 10 is greater than or equal to 2. Absolutely is all the way over here, around here on the number line, so these work. So let's look at the next part. Victoria thinks that 2 is a potential solution. Do you agree or disagree? Yes, we agree. We already actually used that one. We agree. The symbol, like this, translates to greater than or equal to 2. 2 is equal to 2. So there we go. We agreed. I gave us a reason why using the symbol, and 2, just a rational thinking, 2 is greater than 2. So hit pause and jot this one down into your notes. Which of the following satisfies the inequality 5 is less than x? Choose all that apply. This is a key right here, Math Marbles, because it means we may have more than one value for x that will make this inequality true. So let's jot this down. 5 is less than x, or I could even rewrite it as x is greater than 5. Both of these inequalities are just true. I just reversed both sides. Notice the sign also changed. So let's look at this. We have different values for x right up here, and we're going to see which ones make it true. I'll start by making a quick visual, and I'm going to put 5 here in the middle, and I want x to be greater than 5. So I'm going to put the x here on the right side, and this means that every single number, notice I'm opening that circle here, every single number that is greater than 5 will make this statement true. So all the numbers that are greater than 5 will make this true. So just looking up here, and we're just going to think through this. Which of these numbers are greater than 5? Think about it for a second. Well, only 2 of them. 7 and 9 are greater than 5. 3 is definitely not. And can 5 be greater than 5? No. So this one was a tricky one, but that one is also not true. Now, let's also prove it mathematically. We have 2 answers that work here, C and D. Let's also prove it. And I'm going to substitute. Let's see, 5 is less than x. And let's substitute each one. 5 is less than 3. Is that true? No, 5 is not less than 3. 5 is less than 5. Again, no, not true. Now, if this was underlined and it said less than or equal to 5, then I would have a different answer. But here we're just saying 5 is less than 5, and that cannot be true. The only 2 that would be correct are 5 is less than 7. That is a true statement. 7 would be in this area right over here. And 5 is less than 9 would also be true. And because those numbers, these are numbers within this set, this value, every single number or value that is greater than 5. All right, Math Marbles, let's hit pause and jot this down into your notes. And that is it for today's lesson. Just notice how making a visual really helps me just think through the problem, and also consider how sometimes me writing it down in 2 different ways, showing the inequality in both ways with the x in a different position, can also help generate my thinking about the statement. That's it for today. I'll see you in the next one. Be well.